Hi, I'm Oliver Gao. I'm the director of Cornell's System Engineering program. I have been very fortunate to conduct what I call these systems conversations with our prestigious speakers that we bring to our Ezra System Seminar Series. So today I'm very pleased and honored to introduce to you Dr. Chris Atkinson. He is actually the director of Smart Mobility and also professor of mechanical engineering at Ohio State University. And his research focuses on next generation transportation technologies, which we know that there are so many things going on in that sector. Actually, Professor Atkinson, he has not only been in academia, actually I think he did something that is very, I feel, great, I think, for academic research, is that he actually stepped out from 2014 to 2020 to serve as Advanced Research Project Agency Dash Energy, which people call ARPA-E. That I'm very aware of. It's been, I think, creating a lot of impact. It's really, I think, it helps researchers to cross that death valley of research. Right? I think that's very important. And more, I think, excitingly, is that I think Chris recently, he is now, I believe, on detail at the U.S. Department of Transportation as Deputy Director for Advanced Research in the Office of Assistant Secretary for Research and Technology, which I assume is kind of the infrastructure version of ARPA, so which is called ARPA-E. I think there are a lot of things, Chris, with his experience, and also I believe, Chris, I mentioned that he's been also an entrepreneur. Starting up his own company. I think that's a very good combination. So, Chris, welcome to Cornell.
Thank you very much, Oliver.
Yeah, you can see that I'm very excited because I feel, in our traditional academic field, academic world, there are not many people like you having this abundant experience across different sectors. And we are always saying that after we get our PhD. And especially in our PhD training, we were trained to focus on a tiny thing and go in depth and go in depth. But as our career evolve, and actually we somehow become system engineers. And we aspire to be, and we become system engineers because, Chris, as you mentioned, a lot of challenges are system in nature. So, Chris, please tell us more about your fascinating career, because I believe your story kind of reflects a pathway for people to especially for our PhD students to grow up and then aim for impacts.
Thank you very much, Oliver, and thanks again for inviting me here to Cornell and being involved in your seminar series. Yes, I've had a remarkably varied career, as you pointed out. I've received tenure 3 times, as it turns out, at 2 different universities, Ohio State and West Virginia University. Mm-hmm. My undergraduate degree was in chemical engineering, and I have a master's and doctorate in mechanical engineering. As you know, there's significant overlap between those disciplines. Mm-hmm. But the idea is, right from the start, I understood that most problems are multidisciplinary or interdisciplinary in nature. As you said, I've also been an entrepreneur and a federal government employee. So I've seen the same problems, if you like, from at least 3 or 4 different sides. Transportation is remarkably complex. It's an enormous portion of our economy. It's roughly 15% of gross domestic product in the United States. Mm-hmm. It's an area that's very resistant to change, intractable to change, mature in its outlook. There's a large amount of academic work that goes on into the broader transportation realm. Most of it tends to be on the vehicle side, whether the vehicles are ground vehicles or aircraft, rail, marine, aviation. We spend less time and attention on really fundamental academic work on the underlying systems. So it's an area that requires significant work and attention, both from the academic point of view, from the innovation, the research and development, and ultimately the commercialization and deployment. You mentioned my time at ARPA-E for energy. ARPA-E is within the U.S. Department of Energy, as you know, and the idea is to foster innovative technologies and see them through the research and development pipeline, so to speak, all the way to deployment. as you know well too, is that decarbonisation of our economy is an enormous imperative. The United States has stated net zero carbon goals by 2050. And if you split our economy up into transportation, industrial applications, commercial applications, residential, transportation is now the largest emitter of greenhouse gas emissions, and one that requires significant effort in the innovation pipeline that I mentioned in terms of arriving at ultimately this goal of decarbonisation or net zero. However, we can't lose sight of the fact that transportation is both essential to our economy and safety is the number one consideration in transportation, whether it's road transport, marine, rail, aviation, public transit, the operation of pipelines. Safety is the number one consideration. So, long story short, it's the perfect system. It's the perfect system because it's important, it's critical to our economy, it's critical to individuals in terms of them being able to get to where they need to get. Transportation, after all, is the movement of people, goods, and services. And it requires decarbonisation, it requires greater efficiencies, it requires a reduction in its environmental footprint, it requires greater equity, it requires that all sectors of the population have access to transportation and mobility. And as I say, safety and decarbonisation are two very, very critical things that we need to tackle simultaneously.
Wonderful. Thank you so much, Chris. So you mentioned this kind of taking transportation as an example. Actually, I believe many other industry sectors they are presenting similar challenges to our human society. Now coming back to transportation, you're right. They provide us with a utility. They provide us with a value and with mobility service for both human beings and for goods. But in the meantime, they present a climate challenge, and also they present a safety challenge. And of course, when we talk about climate challenge, we talk about greenhouse gas emissions. But the transportation, even before climate change, Clean Air Act from EPA in transportation present the health impact due to the criteria pollutants.
Yes.
So you can see the safety, climate, and also you see that the health. Of course, other equity issues like accessibility due to, for example, different ownership and affordability to such kind of transportation mode. And so this is on the one hand, I would call it kind of what we call the performance measures of any system.
Right.
And on the other hand, kind of potential measures to tackle those challenges. And you mentioned there are technologies, where people, the vehicle technology, there are fuel technology. In addition to these technologies, and also there are different policy instruments.
Yes.
So somehow you have this all multi-objective, multi-metrics that we want to hit. And on the other hand, there is a mesh of all these different potential options, either measures or technologies. And in between these two things that I feel make things more complicated will be the financial market, right? The investment model and innovation and economic development. So I feel a lot of times, right, with humongous challenge and with all these multiple options, and it's very easy for people to feel lost.
Yes.
Where should I start? So
yes.
I'm always kind of making some. Let's say we have a plate of grapes, right. And imagine if you pick each one of them, you don't even. However, imagine that if we have that cluster, right. You only need to pick one point. Right. The whole system moves to the direction. So, Chris, what do you think of all this?
No, I think you've encapsulated it extraordinarily well, Oliver. I would add a couple of other considerations. Energy security, for example. It's not simply decarbonisation and criteria pollutant emissions as you suggested, but it's energy security. And you mentioned very strongly as the notion of equity and access. Social mobility is very closely associated with physical mobility, and human and public health is very closely associated with human mobility. If you can't get to a doctor's appointment if you can't get to a hospital,
Mm-hmm.
your life essentially is in jeopardy. So I like your idea of the deeply intermeshed systems. I would add one more consideration, and that is human factors and human behavior. We typically build transportation systems to last us for decades.
Mm-hmm.
Think of our road system, think of the interstate system, or our rail or aviation systems, for example.
Mm-hmm.
But emphases change, and we're living in a world that's changing remarkably quickly in many respects. And as you suggested, the decarbonisation goals, particularly because of climate change, are enormously pressing. And the question is, how do we take a system that changes on the order of decades and make it respond on the order of years rather than decades?
Yeah.
It's an enormous challenge that we need to take up, and an enormous challenge that we need to conquer. You mentioned the notion of a system. It's very much a system. I like to think of it as you push down at one side and it pops up on the other. It's a multi-dimensional, many discrete dimensions, this system. We typically tend to think only in a few dimensions at a time, and we tackle one particular corner of the problem without full regard to how the whole system evolves. I would mention that. You also mentioned the notion of funding. Again, there's the differential between public funding of fixed infrastructure for transportation, and then things like public funding of transit, and then personal and private funding of people's own individual vehicles, for example. And the timescales and the decision-making procedure across which each of those purchasing and operating decisions are made vary quite widely. That's another issue, which again comes around to the notion you mentioned: policy, regulation, law, but also these human factors and what motivates people. For example, what motivates people to drive? Some of it is very, very obvious. I need to get from A to B. I need to go and do C. But in many cases, it's not altogether clear why people drive, how they drive, why they drive in the manner in which they drive, and how they choose to elect to drive, or how they choose or elect amongst a number of different potential transportation modes. So we need to consider, to a greater extent, human factors and human behavior when it comes to transportation.
I very much agree with you, Chris. From your talk today at noon, and also you just now you mentioned you brought it back, right? The energy security, and I was really actually what I would say enlightened because now the general mental status is that everyone think we're going to electrify everything, right? And especially transportation. But then you mentioned, yes, if you electrify that, and then you become like almost completely dependent on the rare minerals. So that way, that I think that of course will impact the national security.
Absolutely.
Yeah.
Yes, as I said in my talk, we've in 2018 or 2019, the US became a net zero energy importer.
Yeah.
We still import some crude oil, and we export finished petroleum products. We now export more energy in the form of LNG than we import in the form of crude oil. So we've become a net zero energy importer, if you like. And it's something that we fought for 50 or 60 or 70 years for obvious reasons. And on the verge of achieving it, we've now elected to transform transportation for good reasons. Decarbonization is clearly a climate imperative. We've elected to decarbonize and go to electrification, but we've now become 100% dependent upon imported critical materials and minerals. And it's everything from lithium to cobalt to things like germanium, for example, or rare earths for electric machine and electric motor manufacturing. And then, of course, there's semiconductor supply chain issues too.
Yeah.
So we made the conscious decision as a nation to do that. But as you mentioned, is it the right thing to do from a national security point of view? We need to reshore the critical materials pipeline, if you like, in order to be able to control it, is the first issue. The second issue is that we're under a materials constrained condition currently. And so the idea is, if we have a marginal ton of lithium hydroxide or lithium carbonate, which is used for lithium ion batteries, if we have a marginal ton, how is that best deployed in order to reduce our carbon footprint today? And the answer is, it's probably best used in a transit bus, because it has high occupancy and it travels a large number of miles per year in the aggregate. But we don't do that. We put it in individually owned, individually operated vehicles of people who are quite wealthy and in many cases own more than one vehicle. So is that the best use? No, clearly it's not. It's not the best use from a societal point of view. It's not the best use from a decarbonization and climate imperative point of view. But we do it regardless, because the economic incentives are greatest to do so. So the point I was trying to make earlier today was that if we thought about this again as a system, and we considered all of the constraints that you mentioned and all of our optimization parameters that we wish to optimize for, in this case I'm saying specifically decarbonization, we would come up with completely different solutions for our transportation system than the solutions that we currently see.
Yeah, very much so. So, Chris, and you said both you and I, we are both engineers, right? And we, from our undergraduate education to our PhD, and even in our daily work, and we spend a lot of time crunching numbers, and we feel that we are making very important contributions. And now, in the context of what you just said, what a tiny thing we are doing.
I didn't mean to depress you or myself in that regard. The thing that's just I've come to realize over the years, Oliver, is that, as you say, we think very systematically, we think very logically, we like to have systems that we can describe in a deterministic fashion. And there are equations. We might not get them right first time round, but there are equations and there's parameters that we understand and there's coefficients that we can vary, and we can come up with the results that look good, let's say, or fit the dynamics or the outputs of the system. And we are incredibly happy when that happens. And we write papers about them, and we write further proposals, and we get funding, and we educate students, and we think we've done a good thing. In many cases we have. But as I say, the older I get, the more I realize that the component that's missing, the dimension that's missing, is this notion of human factors and human behavior. I don't mean policy and regulation, because policy and regulation, you could force a solution into a particular, it overcomes all constraints, if you see what I'm saying.
Yes.
I'm saying within our chaotic, messy world, we try and find order as engineers and scientists. In many cases, we're able to isolate the order and see how things work. But we tend to forget the notion of individual and collective human agency, the idea that humans do odd things at times, and that needs to be taken into account.
You're right. It's kind of human factors make things more complicated. In some circumstances which is bad, but in some circumstances which is good, because I think these human factors, in the context of AI, right? AI, ChatGPT, they can be programmed to. They possess much more knowledge in a very short period of time than a human being can accumulate through our whole life. Right. However, I feel like AI, they don't have the human factor. They don't have the human factor of randomness and creativity. That's really the source of innovation. So that sense, it provides us with hope to innovate. But in the meantime, right, the randomness also lead to all those random behavior that, from a social aspect, we don't want it to happen, but it happens.
Right.
Yeah.
Right. Yeah, that's, as you mentioned, AI is remarkably powerful and therefore can be used remarkably badly. And so that's worrisome. I give myself comfort in the notion of AI and exactly what you said. It needs an innovative spark. AI is remarkably good at interpolating. It can take multidimensional data. Just to think of a transportation system, you and I, we can think in best in terms of 3 or 4 dimensions at most, where one of the dimensions perhaps is time. But we can't think much beyond that. But of course, AI can think in any number of dimensions simultaneously and can offer tremendous insights. However, all it can essentially do is interpolate. It can only interpolate amongst the data that it's been offered for training purposes.
Yeah.
So that's its limitation. And the fear is that people will ignore that limitation and attempt to use AI to extrapolate. And that's going to be a very, very bad thing when we see it happen. That's point number 1. But point number 2 is, it is just a tool. It's a very powerful tool. As you said, it can have the knowledge of all knowledge that's been digitized. It can have access to that. But where is the creative and innovative spark? And the example that I like to use with students is to say, you can give an AI sort of industrial chat GPT, let's call it, a picture and all of the information about the most successful aircraft ever created in the last 100 years. And you can give it weight and drag and propulsion capability and wing dimensions and airfoil cross sections, and give it all of that information, and it'll design for you, and structural constraints, it'll design for you an absolutely fantastic fixed wing aircraft. But it will never predict a helicopter. It never will, because it has no knowledge of that, and will never have any knowledge of it. And so there you are. Think of the creative spark dating back to Leonardo da Vinci, I believe we're told, of the helicopter. And that, again, that was a creative spark that no amount of AI can create or generate. So I have great hope and faith, Oliver, that you and I will not be made redundant.
I believe so. So I think, Chris, for one thing, right, you mentioned earlier, it kind of because the system or the challenge is so complicated, and also there's all these interdependent components, and then with the plug-in of the human factors. And this is basically the situation. This is basically this is basically the cards we have in our hand to deal with all the challenges ahead of us. So again, it's kind of big. And also, even for all these complicated components, which component should act first? And then which component will come in at the right timing? As I was asking the question when you were giving the talk, it really requires a superconductor that superconductor knows the notes of the whole music beforehand, and it has practiced with the musicians, with the players, tens of times before they can show us a perfect orchestra, right? Yeah. So with that, however, we don't have that luxury, which means that we will not be, we don't even know what next note we should strike.
Right.
That's one thing. However, in the meantime, right, we are talking a lot about optimization. So is optimization meaningful in this context? And second, even you derive with all the information, you derive an optimal solution, an optimal pathway. Will we be able to implement? I'm sure most probably we won't be able to implement it. Right. So in this kind of sense, right, we're facing a lot of uncertainties with all this challenge, both opportunity and challenge, both on the performance metrics aspect and also the solution aspect. Yeah. So now, of course, so Chris, you are right. You're with ARPA-E, which I feel now I realize, as I mentioned earlier, the most important thing is not really about having thousands of engineers crunching the numbers. It's really, in the end, the people on the top making that decision, and designing or pointing to a roadmap, right? So in that sense, I think I feel ARPA-E is really going to be a critical I would say, institutional infrastructure that will collect, academic, industry, and government together. But what would be a possible roadmap or direction?
Sure.
Like to share with us?
That's a really good question. I don't think that any of us could propose sort of an overarching theory or an overarching system architecture for transportation. It is too messy and chaotic, not to use the word in the strict statistical sense, but it's chaotic. I think we can optimize locally. We can find local optima in the system, and we should do that. We shouldn't. What's the saying that people say? Perfection is the enemy of good. If we seek perfection, we'll never find good. We need to come up with these local optima, and you mentioned a roadmap. I think one step more abstract than a roadmap is a vision. We need to collectively arrive at a vision and say, what is our vision for transportation? Some of it, again, is obvious. We wish to decarbonize transportation. Now, having said that, we've already set ourselves down a pathway when we've said decarbonize. If we were to say, make it one level more abstract, which is to reduce the environmental impact or footprint of transportation significantly, that's one more level of abstraction. And you mentioned earlier the constraints that we operate under, minimizing criteria pollutant emissions, optimizing public health, optimizing access to mobility, reducing the net overall cost to society, where that cost is both explicit costs and induced costs and externalities, reducing externalities. These are the things we need to do. So as I say, a roadmap, I think it's probably too premature for us, although we've been at this for 100 years. It's too premature to come up with a roadmap. A vision, we need to agree on the vision first. That's point number one. Point number two is we can look at individual portions of it as it currently exists and optimize those. Now, we don't want to optimize everything in isolation because clearly it's at the interfaces between various subsystems of a larger system that the important things occur. Yes, I'm a techno-optimist. I'm an optimist, ultimately, Oliver. I think that we have the capability to do very much better than we currently do. But in order to get there, we need to agree on the problem. We need to agree on the constraints. We need to agree on the optimization parameters. We need to agree on the inputs and the outputs. And then and only then can we come up with a good system. Now, you mentioned time. Time is not on our side, especially with respect to something like decarbonization. We have to move swiftly, which is, I think, why people are moving as quickly as they possibly can in that particular aspect. Again, earlier on I suggested, it's more than decarbonization. It's things like safety. It's the total efficiency of the system. It's the total cost to society. It's the cost integrated across all of society. In Columbus, Ohio, where I come from, we have in 270, which is a circular ring road around the vast majority of the city. We have 7 lanes each way in places.
Wow.
I still remember when I was a kid growing up, when LA had 4 lanes in each direction. That was Los Angeles. And here we have Columbus, Ohio, the 14th largest city in the United States, with 7 lanes of roadway in particular places. That is a non-optimal system from a societal point of view. Enormous land use issues. It cuts off neighborhoods, for example. Enormous cost. Now, there are times under which all of those lanes are congested, but for the vast majority of time they are not. If you were to build an 8th lane, it would reach congestion at some point too.
That's right, yeah.
We clearly need to do a better job. What about public transit? What about other modes of transportation? The world over, there's examples of cities who have retrofitted metro systems and light rail systems, and car sharing and bike sharing and mobility on demand. These are solutions that are readily apparent to us, but we don't typically look at them too closely.
So Chris, you mentioned this, and also, when you were talking, and I think you and I, we both agree that human factor it's a lot of times ignored, but it's really the most important, and also the human factor is really the most difficult part. And then when you talk about, I really agree with you. If you correct me, before we talk about the roadmap, we should talk about the vision. And it's not only forming a vision by yourself. It's really like consensus building. So that can almost me almost led me to a conclusion that time. I feel probably one key to addressing human factor is consensus building. Mm. It's like kind of you have all these particles that are moving around all these different directions. But however, if you have consensus across all the particles, such that then, because I think to deal with the climate change challenge, we have to have collective actions.
Yes.
In certain directions together.
Yes.
Right, and then that has to be built upon the consensus building, under an agreed upon a vision, right?
Indeed.
Yeah.
Indeed.
So with that, actually, so I want to, because your words also I think kind of stimulated another idea in my mind. Right, we build a vision, and even ARPA-E, right? In the end, you have ARPA-I. Or ARPA-E, right, you have some funding and to be distributed to help new either technology or new model development and new research. That kind of what I'm saying. Assuming that we build a consensus vision, that is, and then when we talk about implementation, and so in this country, actually in many countries in the world, we try to talk about, market will take care of itself. Mm-hmm. We say that there is an invisible hand, mm-hmm. which is a market. Market will take care of itself. Mm-hmm. That's one. And I think, and also I think many people has very, what I would say, very strong beliefs in the market. Of course, the debate happening between among economists, right? Sure. Government or market. So this is one element. Another element is really capitalism, mm-hmm. right? Market and capitalism. Of course, I feel that capitalism is underlying the market. It's really driving the market, and also capitalism is driving the behavior. Sure. Hence, it will really, I think, influence, if not dominate, the implementation of the vision. And one thing that is different, especially the vision, we are talking about the vision of incorporating externalities in the operations of transportation market or power market for whatever. Yeah. So, and this I feel it's a different phenomenon than, for example, before if there is a market that does not have externality, and which is good, the market will take care of itself. Mm. But now with sectors that have significant externalities that were overlooked before, but now you want to incorporate that into the operations of the traditional market, which is kind of so strongly impacted by the capitalism. Yeah. How are we going to be able to put this externality into that? The reason I'm asking is because you're also entrepreneur, and you have touched upon the market. Sure. You have worked with the capitalism. Sure. Because we know that what market is in pursuit of, what capitalism is thirsty for. So that way, do you think that the capitalism and also the pure market operation could distort the vision?
No, that's a really good question. Now we live in a capitalist society, make no mistake, and there's no changing that.
That's right.
Our public infrastructure, by its very definition, public, is owned by the public. It's not privately owned. Of course, there's large amounts of private infrastructure that any number of infrastructure owners and operators own and operate. But the vast majority of the infrastructure for transportation is publicly owned. Now, I see no tension between that and capitalism. We all, as individual actors and agents within a capitalist society, use public infrastructure on a daily basis, whether it's roads, rail, our air traffic control system, our GPS positioning that we have on our smartphones, the pipelines that provide water and natural gas to our homes, or the high voltage power lines that provide power to us, to our homes and businesses and industries. We all use those. We're all happy to use them. Of course, we complain about having to pay for them. But again, I think there's no tension there between publicly owned and operated infrastructure and private enterprises. It's fairly well established. Now, of course, private enterprise, we have public-private partnerships. There are privately owned toll roads in the United States, things like that. Again, there's no tension there. It's, as you well know, when we build a road, we amortize the cost of that over 30 or 40 or 50 years. And there's few commercial enterprises that are willing to do that. They're seeking profits in the next quarter or the next year. So there is a tension between those issues. But again, I see no discrepancy or any tension at large between publicly operated infrastructure and private ventures that use that infrastructure for their individual gain. What are we talking about with respect to infrastructure? Again, it's roads, bridges, ports, airports, harbors, pipelines, our aviation system. And bear in mind further that it's not simply the physical infrastructure, it's also the digital infrastructure that underpins it. So it's the sensing, the automation, the computation, the networking, the communications, the decision making, the software that manages our transportation systems, that goes into infrastructure. One point I would make with respect to the private sector is that transportation is one of our last remaining areas of our economy that has yet to see significant disruption through information and communications technologies. You know, we use the GPS system, we have fairly advanced air traffic control, thank goodness, it's very safe. But there's vast portions of our transportation systems and our infrastructure that is largely untouched by the information revolution. Now, as computing power increases, as networking and communications become ubiquitous, as we become more digitalized across the economy, we need to do the same for our infrastructure. We need to do the same for our transportation systems. And that's a tremendous opportunity for something like an advanced research projects agency for infrastructure, to find those critical persistent problems in infrastructure, have people develop very innovative solutions. And by people I mean academics, innovators, companies big and small, federally funded research and development centers, citizens by and large, have them develop very innovative solutions and that can feed a research and development pipeline that can ultimately lead to deployment. Because we understand without deploying these technologies, there's not much point in initiating them to begin with. And as we've established, we have a tremendously messy system with many constraints, with many potential optimization points, meshing and merging with new ideas in computation, in connectivity, in networking, in materials, in construction methods. Think of 3D printing, for example. Why can't we 3D print a bridge? We have issues with greenhouse gas emissions. We have issues with climate resilience. We need to bring all of these measures to play, all of these systems, there's that word again, all of these components to play to find these persistent solutions to these persistent problems such that we can improve our transportation system.
I very much agree with you about, the infrastructure sector is really, I guess, kind of the least impacted sector by, information technology. And also that presents, tremendous opportunities for the economy and for jobs
It does.
And also, I think for carbon footprint reduction.
It does.
Right. So Chris, with that, I cannot help, thinking, what has held it up? What has held it up? Why, infrastructure has been, falling behind, and what are those factors? And are those factors going to still be with us? Because if those factors are not identified, and this situation could remain the same 10 years later.
That's a very good question. It's the capital costs are enormous for building a road or rail or and the safety, again, the safety is critical. People tend to think of new innovation as being high risk, and it is high risk, but high risk need not be unsafe. By high risk, we typically mean that there's an inherent chance that the technology will fail to mature. That's the technological valley of death that I think you mentioned early on. It's perfectly okay to fail in the laboratory where the stakes are low. And again, by failure, I don't mean failure from the point of view of creating an unsafe system or rendering our current system unsafe. It says that there is a certain inherent technical risk to undertaking this particular approach to solving a specific problem. It may or may not work, but we'll try it out in the lab, we'll try it out in the academic and laboratory setting, and then if it works, we'll transfer it to those people who know best about such systems, people who have experience in commercialization of infrastructure, and then ultimately it can be deployed in the field. And when it's deployed in the field, we wish to see those improvements, reduction in environmental impact, improvements in efficiency, reduction in cost, improvements in transportation throughput, increasing equity and access to mobility, the sorts of things that we know we should be doing and paying attention to while maintaining the absolute gold standard of perfect safety. So I'm bullish on this area. I'm optimistic. I think what we need to do is, it's an area that's been neglected because we've been distracted by loud noises and bright lights, other areas that are easier to find new applications, easier to make money in. But we cannot have a 21st century economy with a 20th century transportation system. And that's what we currently have. So it behooves us to do better. And as academics and practitioners in the field, we need to invigorate and make students more enthusiastic about solving these problems, about engaging with these problems. They're tremendously tricky, but that's what makes them so rewarding in the end.
Yeah, absolutely. Speaking of that, I'll have my second to last question. You see this, you mentioned, right? There's the capital cost for infrastructure sector is so huge, which means that we have to have a lot of funding, which I don't think the government alone can afford that. That's one thing. Of course, you mentioned the PPP, public-private partnership earlier, which is actually, the US is falling behind in, I would say, adopting PPP or practicing PPP in comparison, for example, UK or even, Latin American countries, right? So, but one thing with all these challenges, especially you can see that all these challenges you are mentioning, especially greenhouse gas emissions, these are all externalities that are usually, like the industry, they can now voluntarily consider, right? And we do believe they are very good citizens in the industry. However, given the performance measures of the CEOs that they are evaluated by, right? You can think about even a CEO is really pro-environment, but when they look at their balance sheet, right? They have to make decisions. So my question is that essentially you can see that we need the government to come in, because this is a collective action. This is not individual business or industry, private sector behavior.
Right.
This has to be a collective behavior where the government has to have a strong hand. So now the question, to have a strong hand, we know that a strong hand rely upon talent. So in that sense, does the government have the mechanisms to attract very good talents to their side? Because yes, but especially in this country, even the government, right? They have to be equal with the industry, with the private, to work things out. So in an equal environment, if you want your idea, you want your vision to prevail, you've got to be better,
Right.
and smarter.
Yeah.
So especially for this kind of collective, social goods. So do you feel that the government has good, if not better, talents, and how the government can? Because even in the PPP situation, right? An investment bank, they have their lawyers.
Right.
The government, you have your lawyers.
Right.
So in the end, right?
Right.
They will
Yeah.
finalize, the agreement. Right. So it's really the talent. I feel it's really do we have talents working in the right positions to help us design and implement this collective endeavor?
That's a really good question. The short answer is yes. The longer answer is that the federal government always has a very deep requirement for added technical prowess. And it's a tremendous opportunity, and I would urge people to look very closely at the federal government. There's many mechanisms to contribute. So take, for example, ARPA-E or DARPA, for example, and now ARPA-I for infrastructure. The idea is to have program managers, much like the National Science Foundation, who come in on a rotating basis. They are learned people from academia, small companies, big companies, federally funded research and development centers such as the national labs, and other places, non-profit organizations. And they come in on a term-limited basis to provide the technical backup, if you like, the technical capability that can underpin the funding opportunities. They can write funding opportunities, they can manage programs, they can manage them in a very hands-on fashion. There's tremendous opportunity for that, and I would urge everyone from students to faculty to innovators to practitioners in the field to become aware of the particular opportunities. The second thing I would say is that the federal government, again, is always in need of strong technical assistance. Mm-hmm. The third thing to bear in mind is that it is the federal government, and what it does is it distributes money to the states. And so there's a second tier, if you like, of people working at the states who need to be technically adept and be capable of decision making. The idea is that the federal government doesn't necessarily know what's best for each and every specific region or each and every specific state or locality. And so it works on sending out money on a formula-based basis for infrastructure projects in that respect. So it's a multi-level system. We need people at the local level who understand their transportation systems and the shortcomings of their transportation infrastructure, as an example. We need people at the state level who can coordinate, and then we need people at the federal level too. Just to give you an example, we spoke earlier about critical materials and minerals. This is a tremendously pressing issue, and one that's is disruptive within the industry in terms of the electric vehicle or electrification transformation. The federal government is very well aware of the issues. Now, what can it do? Well, there's limits to what it can do. It can hire experts, it can fund research and development programs in critical areas, and then feed the innovation pipeline that other people can then pick up on the technologies and take them to commercialization. As you know, our US government is remarkably generous in providing free intellectual property benefits to anybody who co-develops processes, systems, subsystems, technologies, capabilities on government funding. And that's why we have the National Science Foundation. That's why we have DARPA. That's why we have the US Department of Energy, ARPA-E, the NIH, the new ARPA-H for health. We have tremendous capacity for innovation. One of the things that I've been trying to suggest is that transportation and transportation infrastructure, for various historical reasons, is one that has been avoided by many people in terms of innovation. And now's the time for everyone, from students to faculty to companies to innovators, to refocus on transportation and transportation infrastructure, both physical and digital, and bring their sharp brains and minds to bear on these critical problems that we have. Because ultimately, as you suggested, it's all for the public good.
That's right, yeah.
An improved transportation system in the United States, whether it's roadways, marine, rail, aviation, benefits all of us. Benefits all of us in a myriad of ways. Benefits our society, benefits our economy. And so it behooves us to place more emphasis on solving these persistent problems.
Yeah, I think this is wonderful. So I think in this context, I feel ARPA-E can really play a very important role in not only carrying out like kind of DOT's vision for the future mobility infrastructure, but could even help change some of the internal culture within DOT for it, because the DOT is really traditional, old traditional, right, kind of a system, because maintaining this, as you say, kind of the 21st century economy, but DOT is trying to maintain this, at least given its current funding capability, probably making its end meet to maintain this 20th century infrastructure.
Yes,
right.
No, and as infrastructure becomes more and more expensive, because it simply does,
That's right.
we need to find new and innovative ways of reducing the cost, but not compromising on the environmental impact, not compromising on access, not compromising on creating greater externalities that we somehow have to deal with at some point in the future. We're fully aware of that now.
Yes.
We weren't aware of that in previous decades. We used to sweep things under the rug. But we're now aware that we can't do that. So again, it comes back to your original supposition that we have, these are the parameters we're attempting to optimize. These are our constraints. We have other externalities in terms of things like human factors and behavior that we've established today are extraordinarily important. And we need to optimize the system, in many cases, for decades of operation. It's a tough problem, make no mistake, but that's what makes it so worthwhile and encouraging.
I very much agree with you. So that way, kind of just last question. So for, we talk about talents, and of course you and I are both in the education, higher education sector, right? And I guess probably in early years when we start our higher education career, we focus on teaching a very technical subject, right? How do you derive this derive some of this differential equation? We feel good. We teach students to do these things. But now look at the issue, the challenge, and you are talking about, and also the huge, I think the huge workforce gap. You need people to come to address these things. So for system engineering students, what kind of curriculum or where would you direct their attention to while they're pursuing their degree, either here at Cornell or anywhere in a higher education institution in any major? But you can, because I think your view is going to be very unique, because you are in academia, you work with the federal government, and also you connect with the industry. And all these sectors, they need the right talent. So what should be in that right talent?
That's a really good question, Oliver. I believe that when you and I were students, it was a very siloed very set sort of curriculum. We had electives, of course, and we could, to a certain degree, we could shape our higher education. But to first order, at least, it was pretty well described and pretty well prescribed. Nowadays, students have an enormous array of potential areas that they can cover, both in terms of coursework and projects, and of course, as graduate students, they can span a much broader area. So I would say the things to do are to have technical depth to begin with. You need to have technical depth, but then you need some sort of societal broadness. You need to have an awareness of these problems, these greater societal issues that we mentioned. And the ones that are most pressing today are, of course, climate change, safety, equity, and the general efficiency of the system, where that efficiency can be measured in terms of dollars and cents, but in other ways too. So be aware of the environment in which we all operate, the fact that technology is changing radically. We can't be blinded by rapid movements in technology. Now, to go back to AI, for example, artificial intelligence, it's a wonderful tool. It's a wonderful tool, and tools are very good things if they are used correctly, and if they are used in a safe fashion, to use that word again. So people and students and practitioners need to understand the bounds in which to use these specific tools. But what's so encouraging today is that students are encouraged to have a very broad outlook, far broader than when I was a student. And that's an incredibly valuable thing to do. So a broad outlook with deep technical depth in one area, in a specific area, or perhaps a couple of areas, that can then be brought to bear upon very critical societal issues and needs. And there's not a greater one than transportation and transportation infrastructure, for exactly the reasons we've mentioned. It's been neglected to a large extent. The methods that we use are 100 years old in many cases, and it's crying out for new innovative solutions. So a very encouraging area to cover.
Wonderful. Chris, thank you so much. You talk about, these two aspects, the technical depths and also the societal awareness, the breadth of societal awareness. This kind of reminds me, because for system engineering people, we are always trying to explain to people, what is exactly system engineering? What are you trying to do? And we say that, we try to equip the student with what we call a later T-shaped knowledge structure.
Right.
Later this vertical is the technical depth.
Right.
That's why we don't have undergrad degree. We only have graduate degrees for system engineering. Right. They come to us with certain level of that vertical, and then we help them build this horizontal bar to form a T-shaped knowledge structure.
Yeah.
Chris, thank you so much. It's really a great pleasure and honor to talk to you.
Thank you very much, Oliver. I greatly appreciate it, and thanks for the invitation to talk to you.
Wonderful. I think we're all set.